Okay, let's get into the analysis. We've captured the evidence. We're ready to go. We need to do an assessment, examination. You can call it assessment or examination. Those two things kind of run together. And then we're going to look at the extracted data. And we've seen previously about time frame analysis, data hiding, and applications and file analysis. Remember, you're going to get a large quantity of information. And you have to prioritize what's rational and what's real and what's possible. Sometimes you've got to collect evidence that's used to then go collect other evidence. Sometimes you can seize the cell phone, pull the information off of it, and instead of starting to dig into, not on a cell phone, but let's say the registry of the cell phone or the operating system of the cell phone, you just look at the last number dialed. And that's the thing that you need to grab right away so that they can say, oh, made this phone call at this time. This proves that the other end of the conversation was that person over there. Now we use this to go get another warrant to seize their information over there or their computer over there. That prioritization of collecting the things that will allow us to have the other people in the law enforcement actually go take other actions, we prioritize. We make it good for them. So pick the evidence, the low-hanging fruit that's out there, and look for the stable media examination as opposed to the volatile media examination. Even though you may pull the volatile information right away off of that computer through a RAM dump, you don't examine that first. You examine what's actually on the hard drive. You're going to have to set up your document for the evidence, photographing, sketching, so that you have to say, okay, well, here's my evidence, and this is what it looked like when it was in that place. Look at your storage locations when you're dealing with your evidence to make sure that they actually protect it so that it doesn't degrade over time. Remember, this is magnetic in nature most of the time. It's very rarely that it's optical. Sometimes you do have the luck of DVDs. Optical is much more stable for a longer period of time, whereas magnetic media, not so much, especially when it's stored around other magnetic media. Figure out what the state of that evidence is when it was packaged, transported, and stored, because remember, you might get a bag full of cell phone parts. And so hopefully what happens is they individually bag them so that you can reconstruct that cell phone correctly. What you don't want is a whole bunch of cell phone parts banging up against each other and then mashing in and making something more crushed or more screwed up than if they would have separated them out and you could rebuild it. Again, power supplies are a big tool out there. There are great tools out there for that. It's not very expensive to supply power from the original location back to your forensic lab. You have to prepare for that up front, and you need to know a little bit about electricity or it'll be very painful. When you conduct examinations, remember that examiners must use accepted forensics procedures and avoid using the original evidence. I can't stress that enough. You're going to hear that probably 10 or 15 more times as we go through the course because it is so important. I would bet, just a guess here, that if you knew these basic principles and you could apply them in your test and you learn nothing about the technical, I would bet that that could help you through about 15 to 20% of the exam. Just by knowing those principles and applying them, you could get 15 to 25% of your exam passed pretty well. Physical extraction methods. Sometimes this is called carving. And what we're doing is we're actually creating a list of keywords that we apply in a particular situation to the actual physical media itself. We're going to say this is what we're looking for. We're looking for evidence of drug smuggling. So probably one of the words that you would put in a keyword search to look through the computer quickly would be drugs, right? Or the slang terms for drugs. So you would create that keyword search that's appropriate and then apply it across that data and say, all of these files in here have the word drugs in them or have the word this in them, whatever that slang term is. So those are the first places that we're going to look. It'll help you prioritize. Now, some tools, what they'll do is they'll actually run the index against the entire data set before you actually do the search. So they have all the different words keyed into a database. That makes them a little more elegant so that when you search for it, it doesn't have to go through the entire hard drive or the entire image in a serial fashion. It says, I already know that these words exist. Which ones are you looking for? And it pops right out. Keyword searches on physical drives. You can also do that on logical drives. Usually what we do is against the physical drives themselves. File carving utilities process across the entire physical drive itself. This is actually looking for the pieces of evidence, and we'll explain file carving in a little bit. You also want to examine the partition structure. A key thing that happens in a lot of cases is we create the normal partitions, and then on top of that somebody says, well, I'll hide a partition. So we'll say this drive is 100 gigabytes in size, and there are two partitions, both of 49 gigabytes. What about the other 2 gigabytes? What's going on there? Is it a hidden partition? So you want to look at your partition information when you're doing your physical extraction. Now we need to flip over to the logical side of things. We've been looking at it from a hard drive bits and bytes level or a hex level. Now we'll say, okay, what does the logical look like? And that is the file structure according to the operating system, not according to everything that's laid out on the drive. You can also, in that logical extraction, you can look for file slack. Look at the definition here. Space that exists between the end of a file and the end of the last cluster used by that file. You say, well, so what? What about that file slack? Well, there's data sitting in there that's from a previous time, especially if this is a rotating media, especially if this is a physical media. So it may be that they had a file in there and they said, okay, I'm going to delete that file, and all it does is remove the pointer to that file. And then the new file that's written to that space only takes up a little tiny bit of the area that was there originally. And through logical extraction, what we could say is, here's the regular file, but then there's all this other little space in there that's got an old file in it that we want to take a look at. We're going to examine that in one of the other sections. Let's look at the steps. We're just going to wrap up these steps for a second here. Extraction of the file system information, so you'll pull that data. Reduction of the identified data gets rid of the known files, all the things that you know to be consistent and true and that you've proven, because remember, you're going to have to look at that particular executable for the operating system and say, was it the truth? And you're going to have to go to your reference system and say these two are the same. So we'll exclude all of that extra stuff. Find those pertinent files for the examination. In other words, now we've narrowed it down to these things are operating system and the operating system is consistent. These are the applications and the applications are consistent. Now let's pick up all the other stuff, including the registry. That's a big deal on the Windows systems. If there's any deleted files, we want to recover as many of those as possible. Sometimes that's done inside the running operating system, and sometimes it's done outside the running operating systems. It depends on how the computer's set up at that point, or when you arrive on the scene. Is the computer running or not? And we want to extract all the file slack to see all those pieces of leftover, those remnants that may help us and guide us and be some true evidence for us to use.